Hi everyone, I'm Oscar Nartal and I'm a mechanical engineering student at Bilkent University. Today I will perform an experiment which is called studying spring constant and the period of oscillation. In this experiment, the effective spring constant and the period of the spring oscillation will be examined. I will attach two identical springs in series and in parallel, and by the relationship between the period of oscillation and the attached weight, I will find the effective spring constants. The aim of this experiment is to compare the effective spring constants with the theoretical values from the equations. Our equipment are two identical springs, 4 different weights, one ruler, and one stopwatch, and a holding pin. First, I will find the spring constants of the identical springs by the change in displacement of the spring's length. By the equation mg equals k times x, I will find an average value for the spring constant after performing the experiment with 4 different weights. Then I will attach the springs in series and perform the experiment with attaching 4 different weights. I will measure the period of oscillation by a stopwatch and find the effective spring constant due to the relationship between attached weight and period. Then I will compare the result with the theoretical equation we use to calculate effective spring constant. The 4 different weights I use are 10 grams, 20 grams, 50 grams, and 100 grams. After that, I will attach the springs in parallel and perform the experiment with the same 4 different weights, 10 grams, 20 grams, 50 grams, and 100 grams. I will measure the period of oscillation again by a stopwatch and find its effective spring constant in parallel due to the relationship between attached weight and the period of oscillation. Then I will compare the result with the theoretical equation we use to calculate the effective spring constants while attaching the springs in parallel. Through the graphs of attached weights versus the period of oscillation, both for springs in series and in parallel, the relationship between mass and period of oscillation, which gives a linear graph, was found to be the square of the period of oscillation and the mass of the attached object. For the springs attached in series, the error was found 8.9%, while in parallel it was found 2.9%. The possible reasons for the error values are due to human error and neglecting the spring's mass and the air friction.